You see them every day, right? They're just kinda there, the silent green background to our lives. But have you ever stopped and really wondered how they actually work? Well, today we're gonna decode the secret language of plants, and I promise you will never look at a simple leaf the same way again.
I mean, seriously, just think about it for a second. That tiny little weed pushing its way through a crack in the pavement, or those massive trees that give us shade in the summer. They're not just scenery. They're literally the reason we can eat and breathe. They're the foundation for pretty much everything.
So that's the big question, isn't it? How do these things actually tick? All right, let's dive in. Think of this as opening up the user's manual for the plant kingdom. We're going to peel back the layers and see what's really going on, starting right from the ground up.
Okay, so every good investigation starts with the most obvious evidence, right? We're going to start by sorting our suspects based on what we can see right away, their size and their shape.
And you know what? It pretty much all boils down to the stem. Is it green and kind of soft? Well, that's an herb. Is it hard and woody but with branches starting way down near the ground? You're looking at a shrub. Or does it have that big, thick, woody trunk with branches way up high? Yep, that's a tree. These simple categories are a first big break in the case.
All right, now that we've got a basic idea on our plant, it's time to, well, literally dig a little deeper. We're going underground to investigate the root system. This is where the real action begins.
First up, you've got the taproot. The easiest way to picture this? A carrot. A carrot is a perfect example of a taproot. It's this one main dominant root that just drills straight down into the soil, acting like a super strong anchor and a primary pipeline for water.
And then you have the complete opposite, fibrous roots. Have you ever tried to pull up a big clump of grass and a whole chunk of earth comes with it? Yeah, that's the power of these things. It's not one big root, but a whole dense mat of smaller roots spreading out. They're amazing at soaking up surface water and holding soil together.
So you see, whether it's one deep anchor or a wide spreading net, the mission is exactly the same. Drink up all the water and minerals you can find and hold on tight so you don't fall over.
So from the roots, let's travel on up into the stem. This is basically the plant's internal superhighway, connecting that dark, hidden world below ground with the bright, sunny world up top.
And you can actually see this superhighway in action with a really simple and cool experiment. If you put a plant stem in some water with a bit of food coloring, you can literally watch that color get pulled up, defying gravity, through all these tiny tubes, making its way all the way to the leaves.
But here's the really neat part. This isn't a one-way street. While all that water and minerals are traveling up from the roots, you have a whole other system that's sending food, which is made in the leaves, down to nourish the rest of the plant. It's a bustling two-way flow of traffic all day long.
And that brings us to the leaves. These are the plant's incredible solar-powered food factories. This is where the real magic happens. But the leaves also hold a very important secret, a hidden code that can tell you almost everything about the plant's design.
And that magic, of course, is photosynthesis. It's this unbelievable process of turning sunlight into life. It's not just how a plant feeds itself, it's the engine that powers our entire planet. It's what creates the very air we breathe. No big deal, right?
Okay, but back to that secret I mentioned. Do you know the intricate patterns of veins on a leaf? Well, they're not just there to look pretty. No way. They are a secret language, a hidden map that reveals the plant's deepest secrets without you ever having to touch a shovel.
So, to crack this code, you only need to recognize two basic patterns. The first is called reticulate venation. That's just a fancy way of saying the veins form a net-like web. The other is parallel venation, where the veins run in nice, straight, orderly lines right next to each other.
And here it is, the big reveal, the secret connection. Get this, a leaf with that net-like, webby pattern will always have a deep taproot. In a leaf with those straight, parallel veins, it will always have a shallow, fibrous root system. Just by looking at the leaf, you're a root detective. You know what's happening underground.
So, we've cracked the code of the roots, the stem, and the leaves. Now, let's turn our attention to the grand finale, the plant's ultimate masterpiece, the flower.
Now, for all the breathtaking variety out there, most flowers are built from the same four basic parts. You've got the sepals. Those are like the little green bodyguards protecting the bud. The petals, of course, are the big flashy advertisements designed to attract bees and birds. And then the stamens and the pistil are the intricate machinery of reproduction. So, when you put it all together, you realize a plant isn't just a collection of parts. It's a masterpiece of engineering.
An amazing symphony of interconnected systems where every single piece, from the deepest root to the brightest petal, plays its part in perfect harmony.